Okay, so this is lecture 25. Please excuse me, I'm a bit under the weather today, so if my voice comes out a little hoarse, that's why. Anyhow, I thought we'd do a general review about the topics covered in the last class. So that's arithmetic sequences, geometric sequences, and partial sums and summation notation. All of those things I'd like to go over and explore in a little bit more depth. So the first part will be a review of arithmetic sequences. So, recall the general term of an arithmetic sequence is given by a sub n equals a sub n plus d times n minus 1, where a sub 1 is the first term, d is the common difference, and a sub n is the nth term. Now I hope that you're taking notes while I'm writing this. I hope you'll treat this like a regular lecture and you'll take notes. Otherwise the lectures are going to be completely useless, as they would be in class if you don't take notes. So please take notes while I'm giving this lecture. Okay, so let's take a look at an example. Why is there an n minus 1 here instead of an n? Let's try to figure out why that is. I reviewed this a few times, but I really want to make it abundantly clear. So let's consider the following sequence: 100, 125, 150, 175, and so on and so forth. So this sequence, the common difference is 25. You're adding 25 from term to term. Now let's organize the information as follows. This is n, and this part will be n. This column will be a sub n, and this column will be the number of times we added 25. Okay, so the number of times we added 25. So the first term is 100. And how many times have I added 25? Well, 0 times so far. The second term is 125. And how many times have I added 25? Well, 1 time so far. Third term is 150. I've added 100 twice now. I've added 25 twice now. Excuse me. Let's enlarge this. The fourth term is 175, and I've added 25 3 times. Okay, so hopefully you see the pattern. Let's do one more. So in general, the nth term, I'll have added n minus 1. I'll have added 25 n minus 1 times. Okay? The first term you added it 0 times, the second term you added it 1 times, third term you added it twice, fourth term you added it 3 times. So the nth term you'll add it n minus 1 times. And so that's why, from here, that's why a sub n is a1 plus the common difference, which is d, times n minus 1. You added d n minus 1 times to get the nth term. Okay? All right. And it's similar logic for geometric sequences. Recall, this is just a review, recall the general term of a geometric sequence is given by a sub n is equal to a sub 1 times r to the n minus 1. Now, why is there an n minus 1 instead of an n there? Well, let's consider the following example. I'll go on to the next slide. So hopefully you have this written down. So we're trying to figure out why is that true. So let's consider this guy. 3, 6, 12, 24, 48. So we're starting at 3 and we multiply by 2 with each iteration. So 2 is our common ratio, it's called. 2 is the common ratio. That's this r term here. Now let's try to figure out how we would derive that equation there. So again, I'll make that chart. Here's n, here's a sub n, and this will be the number of times we multiplied by 2. So this is the number of times we multiplied by 2. So n here, the first term is 3, and we've multiplied by 2 0 times so far. The second term is 6, and I've multiplied by 2 1 times. The third term is 12, and I've multiplied by 2 2 times. See, I multiplied by 2 here, and multiplied by 2 again. The fourth term is 24, and I've multiplied by 2 3 times. So 1, 2, 3, and hopefully you see the pattern in general. On the nth term, I'll have multiplied by 2 n minus 1 times. And so from here we can derive this nice expression, a sub n. The nth term will be a sub 1. That's what you started with. You started with a sub 1 times, and then you're going to multiply by r. How many times? N minus 1 times. Okay? And so that's why the nth term of a geometric sequence is given to be this. Now, you have to memorize that in the exam. That's not going to be on the reference sheet. You need to know that. The only thing that's going to be on the reference sheet is the ellipses and all of the information that I gave you on the lesson regarding ellipses. Okay, so both of these, please have these memorized. This is for the arithmetic sequence, and this is for the geometric sequence. Now, generally, sometimes, let me just look at my notes here. Generally, sequences are neither arithmetic nor are they geometric. Most sequences are neither of those. So I'll give you an example here. Nonetheless, they can be structured. So here's an example of a sequence. 1/3, 1/4, 1/5, 1/6, 1/7, and so on and so forth. This is not an arithmetic sequence because you're not adding anything to get from here to here consistently. And it's not a geometric sequence. So to go from here to here, I need to multiply, if you can check this, I need to multiply by 3/4, okay? But to get to here, from here to here, I need to multiply by 4/5. Okay, you can check that. When you multiply this thing by this, you get 1/4. Multiply this thing by 4/5, you get 1/5. So generally, this is neither arithmetic nor is it geometric. However, that's okay because there's still a pattern here, and we can think about what that pattern is. I'm going to make this a little. I'm gonna do this here. So this is n, and this. So if this is n, well, this is the first term. This is the second term. This is the third term. This is the fourth term, and this is the fifth term. To get the nth term, what am I doing? Well, let's see. Every time, every element in the sequence has a 1. It's 1 over something. But what is it over? Well, this is 1. 3 is 1 plus 2, right? This is just 1 plus 2, and this is 2 plus 2. And this is 3 plus 2. And this is 4 plus 2. So the nth term is just going to be 1 over n plus 2. Okay? 1 over n plus 2. So a sub n is equal to 1 over n plus 2. And if I asked you, hey, what's the 12th? What is the 12th term in this sequence? You could just continue this on for 12 terms, and that would be okay. Or you could use this formula that we figured out here, well, I know that a sub 12 has to be 1 over 12 plus 2, which is 1 over 14. If we're going to extend this pattern out up to the 12th term, you would get 1/14. Okay, good. Let's do another one. Suppose that I gave you this thing. I gave you 1 over 1. I'm writing it like this for a reason. 1 over 4, 1 over 9, 1 over 16, and so on and so forth. Well, could you guess the pattern here? Well, let's see. If you're having trouble with it, you can make this chart. I know this is the first term, this is the second term, this is the third term, and this is the fourth term. You did this probably, you did a baby version of this in grade school where you had the rule, you had some inputs and you had an output and you were supposed to guess the rule. Well, what's the rule here? Well, again, I'm just doing 1 over something where, well, look, this is 1 squared. This here is 2 squared. This is 3 squared. And this here is 4 squared. So this is 1 over n squared is what I'm doing. So a sub n is 1 over n squared. Let's do something a little bit more challenging, and I think this will be the last one here. So let's say I gave you something like this. 2 over, let's say 7. And then 4 over 10. And then 6 over 13. And then 8 over 16. And so on and so forth. Well, let me do one more actually. So 10 over 19. Okay. So what's going on here? What is the nth term of this sequence? What is the nth term of this sequence? Well, look. This is the first term, this is the second term, this is the third term, fourth term, and fifth term. And the trick is actually just break it up. Look at what's happening on the top, and look at what's happening on the bottom separately. Look at these two as separate, okay? So up here, this is an arithmetic sequence, or you could just think, all right, if this is 1, this is 2. If this is 2, this is 4. This is 3, this is 6, and so on and so forth. So if this is n, on top I'm going to have 2n, okay? And then here, this red guy, if you were to separate it, if you were to separate this 7, 10, 13, 16, 19, oh, well, that's just an arithmetic sequence. That's just an arithmetic sequence. I know that this arithmetic sequence, a sub n, is going to be a sub 1 plus, what's the common difference? It's 3 times n minus 1. And I'll just write that over here. So it's going to be 7 plus 3 times n minus 1. Now, you could simplify that. I don't really care. So that means finally our answer, let me move this over. Let's move this here. So that means finally our answer is the nth term in this sequence is 2n over 7 plus 3 times n minus 1. Now if I asked you, hey, what's the 100th term of this sequence? A sub 100 is going to be 2 times 100 all over 7 plus 3 times 100. Let me ask you for the 101st term. That's what I meant to do, just so that the numbers turn out nice. So this is 2 times 101 over 7 plus 3 times 101 minus 1, which is on the top you get 202 all over, well, this is 307, and you can just leave it like that. I don't think it simplifies, but either way, you can leave it like that. So that is the 101st term, and that's much easier than actually writing out 101 terms.